But in 5.4, we are going back to factoring polynomial expressions. So I know we already covered this and did many days and lots of practice on factoring, but we are officially covering it in chapter 5 here. So if you guys did a good job of learning it the first time, this should be a pretty painless process. So the first type of factoring and step number 1, every time you factor, is by taking out the greatest common factor. So remember, the greatest common factor is you will look at both parts of each term. So for my first example here, I have 4g to the second power minus 2g. So out of my coefficients, my greatest common factor between 4 and negative 2 would be a positive 2. So I can factor out a positive 2. And then as far as my variables go, I have g squared and g. They both have, a g in common. So I can also factor out a g. Okay, so if I factor out 2g, if I take 2g away from 4g squared, I'm still going to have 2g left over. If I take out 2g from negative 2g, I will have negative 1 left over. So for a greatest common factor example, this is as far as I'm going to factor it. Okay, the next type of factoring that we talked about earlier this year was the difference of two squares. So remember, if you have two perfect squares and you have a binomial like this, you can use this shortcut. That is the formula. Please write that down. So for difference of two squares, my a value is going to be the square root of x squared, which would just be x. So my a value is going to be x, and my b value, which is the square root of my second term, is going to be 1. So using my formula, I'm going to have a, which is x, plus b, which is 1, times a, which is x, minus b, which is 1. So that would be my factored form for example number 1 there. Okay, skipping ahead to number 3. Remember, even when you have a difference of squares scenario or a factoring trinomial scenario, you still have to look to take out a greatest common factor. So number 3, first looking at my coefficients, it appears that I can factor out a 4 from both 4 and 400. So the first thing I'm going to do is factor out a 4, which leaves me with x squared minus 100. Okay, both 1, which is my coefficient on x squared, and 100 are both perfect squares. So once again, my a value, which is the square root of x squared, is x, and my b value, which is the square root of 100, is just 10. So using my formula, I've got 4, don't forget your greatest common factor, times a, which is x, plus b, which is 10, times a, which is x, minus b, which is 10. So that's my factored form. Okay, please try all of the examples on the right side on your own, but I'm not going to take time in the video to go through them. All right, factoring trinomials with a leading coefficient of 1. This is the factoring skills that you guys got really good at. Remember, this is the whole AC method. So we need to find two factors that would multiply to negative 10, multiply to your C value, and add to your B value, which is 3. Okay, those two factors would be a positive 5 and a negative 2. So you can write this directly in factored form as x plus 5 and x minus 2. And that's my final answer. Okay, similarly with number 3, I don't have a leading coefficient of 1 as of now, but you guys could probably guess it by the section we're in. If you take out a greatest common factor, you could make this problem so it has a leading coefficient of 1. So my greatest common factor in number 3 would just be a positive 2, which would leave me with an x squared minus 8x plus 20. Once again, I need to have two numbers that multiply to 20 and would add to negative 8. My two factors for this scenario would be negative 10 and positive 2. So I can write those as my two factors. Make sure you don't forget your greatest common factor. So I have x minus 10 times x plus 2. And don't forget your 2 out in front. Okay, I know we've done a ton of examples of that style of factoring, so that shouldn't be anything too difficult. Okay, the next style here is factoring trinomials with a leading coefficient other than 1. So for one of these examples, I am going to use factoring by grouping, and the other one, we can use the whole-in method, because I know you guys some prefer one over the other. So for the first one, I'm going to use the grouping method. So remember, for grouping, you'll start by taking a times c. So 2 times negative 5. AC is going to equal negative 10. And then obviously my b value just equals positive 9. So I need to think of two factors that would multiply to negative 10 and would add to 9. Okay, my two factors are going to be negative 1 and 10. So that's how I'm going to make my grouping. So I'll have 2x squared minus 1x plus 10x minus 5. Remember, for your grouping, all you're doing is breaking up your b value. And then I'm going to separate my two groups. Okay, from each of these groups, I'm going to factor out a greatest common factor. In group 1, my greatest common factor is just x. So I have x times 2x minus 1. And for my second group, I can factor out a 5. So I have plus 5 times 2x minus 1. Okay, now remember, you group your two greatest common factors, and then you group your leftover. So my factors end up being x plus 5 times 2x minus 1. All right, so that is factoring by grouping. So I know about half of you like to do that. Next, we'll do the whole-in method. So remember, before anything, we have to look to see if we can take out a greatest common factor. In this case, we can factor out 2 as our greatest common factor. So I've got 2 times 6x squared plus x minus 2. So remember, for the whole-in method, you are going to take your AC still. So my AC of my newly factored formula, so 6 times negative 2, is going to give me negative 12. So I'm going to substitute my function. I'm going to substitute negative 12 in for my C value, and I'm going to drop my leading coefficient. So I have 2 times x squared plus x minus 12. Okay, I'm going to factor that to start. So I need two factors that multiply to negative 12 and add to positive 1. Okay, I immediately think of positive 4 and negative 3. So I'm going to write that as my two factors. So I've got 2 times x plus 4 and x minus 3. So remember, for the whole-in method, you need to divide your leading coefficient. So I'm going to divide by 6, and I'm going to divide by 6. The next step is you have to simplify both of your fractions. So I've got 2 times x plus 4, 6. I could divide both of my numerator and denominator by 2. So that would give me 2/3. And then I've got x minus 3, 6 just simplifies to 1/2. Okay, once you're here, this is where you'll do the bottoms up, which gives you 2 times 3x plus 2 times 2x minus 1. Okay, and those are both of your factors using the whole in method. So it is really up to you how you want to factor those trinomials. It does not matter to me. All right, the final factoring section, which is different from what we've covered, is factoring by grouping when you have 4 terms. So 4 terms actually works out quite nice. So as long as it's written in standard form, you're just going to group your first 2 terms and your second 2 terms. Okay? From here, you're going to look to factor out greatest common factors of both of these terms. So my greatest common factor of my first group would be x squared. So I've got x squared, and what's left over is x plus 2. From my second group, I can factor out a 3. So I've got plus 3 times x squared plus 2. Okay, at this step, you should notice that both of your leftover factors are the same. So I can group my greatest common factors and my leftover factors, which gives me x squared plus 3 times x plus 2. Okay, and for this case, that is my most factored form. Sometimes you could factor it one more step, but in this case, we have to leave it. Okay, moving on to number 3, same exact process. We will make our groups. Then we'll factor out our greatest common factors. So my greatest common factor in my first group, once again, is just going to be my variable squared. So I'll factor out a z squared, which will leave me with z minus 1. And in my second group, I can factor out a 5. So I've got plus 5 times z minus 1. So both of my leftover factored portions are the same. So I'll combine them, which gives me z squared plus 5 times z minus 1. And that is my factored form. Okay, so try those other 2 on your own. This is really the only new kind of factoring that we're introducing in this section. Finally, factoring flowchart. Please copy this down somewhere in your notebook. It tells you all of your different options for factoring depending on the number of terms that you have. So take a little bit of time. Please copy this down. In class, we can finish the rest as a quick review before we get started in class. All right. Thank you guys for watching. Please come with any questions.